Excellent, thank you. Welcome. This has been, so far, the most fun I've had at a SciPy conference, and it's only, I think, day 3. So I hope you're all having as good a time as I am. If you're not, you should be trying harder. The website that I'm pointing at right now is hashdist.github.io. This is where sort of the package that I'm going to be talking about lives. It's my best effort at making something cute and nice and friendly and showing you how to use this thing and what's going on. I'm going to give you a much better demo in the next 15 minutes of kind of what's going on in this package. If somebody's a web developer and has opinions about this, please give me a pull request. Okay, so this is the talk. Reproducible, relocatable, customizable builds and packaging with HashDist. It is, I think, the wordiest talk I've given since my PhD thesis. Of course, the short name is Don't Fail at Packaging. Okay, so I said a few things. I said reproducible, I said relocatable, and I said something else. I'm going to go back there and see what I said. Customizable. Okay. Why do you care about reproducible? Does anybody here not care about reproducibility? You can raise your hand. It's okay. All right. Well, Victoria Stodden has done an excellent job of summarizing where we are, not necessarily the SciPy community, but as a scientific community as a whole. And we're at a crisis of credibility because our software products are not reproducible. Actually, not our software products. Our research products are not reproducible in a grand sense. And I'm not going to talk about the big problem. I'm going to talk a little bit about what some people have been saying about it, right? So this is a very good quote by David Donahoe, who happened to be our advisor. You might know him from some of his research, but let me just repeat this word for word. An article about computational science in a scientific publication is not the scholarship itself. It is merely advertising of the scholarship. The actual scholarship is the complete software development environment and the complete set of instructions which generated the figures. I think if you have published your code on GitHub, you've done better than 99%, right? You're in that 1%. But you're probably not paying too much attention to the complete software development environment. You know, we've had a couple of talks about it. Using virtual machines and tools like Conda to help make it easier to package things. But I'm going to solve this problem completely for you in the next 15 minutes, right? That's the promise, right? I will solve the complete software development environment problem in the next 15 minutes.
Thank you.
Okay. So what was the software development environment 30 years ago? It was a substantially easier problem, right? Here's my Fortran file. I hope you've got a compiler that can handle, you know, my special stuff. There may be pointers and arrays in here. Sorry. Right? 10 years ago, people started thinking about makefiles, and maybe you needed a C++ compiler with a specific version, but things were still relatively self-contained. The story today is no such thing, right? If you are using any sort of other software from other packages in the ecosystem, you have a large stack, and this is not as bad as it gets. It gets worse. Okay, so that's the reproducibility side. I'm going to come back to it in a little bit, how we solve that. But why is relocatability important? Does anybody know? Anybody care about why relocatability is important? I can tell you why it's hard, right? That's because dynamic libraries tend to hard code paths, and so do scripts. Some of the best scripts you use hard code paths just to make things hard for us. And in addition to this, most system package managers, if you use apt-get, if you use yum, they just install into a common location every single time, right? You can't ask apt-get to install a package into a user local directory. And this is why relocatability is really hard. I will tell you there are two people who have done a really good job, two groups that have done a really good job solving this problem. Well, Conda has done a better job of solving this problem than us. We are now solving this problem as well. But anyway, why would you want relocatability? Why would you go find a hard problem except for the challenge? Multiple versions, making it easier to link things in. Actually, you can do it without relocatability. So Homebrew does this, right? They have multiple versions of builds available, and they use symlinking, but everything still has to live in user local. And if you don't put things in user local, things sometimes break. Okay. The reason you want it is because you want binary builds. And the reason you want binary builds is because binary builds are fast, right? We have binary builds. We can quickly download what Homebrew would call it a bottle. You would call it maybe a binary RPM. You don't have to build everything from scratch every time somebody compiles and installs something. So this is something we want to take advantage of. So here are some things we want. We want reproducibility, we want relocatability, and finally we want customizability, right? So customizability is a tricky thing, right? Most people will say, but I just want to pip install SciPy. But I'll then ask you, what do you want from SciPy? And which version of SciPy do you want? And where's your laypack coming from? And maybe you don't care about where your laypack comes from, but if you're worrying about reproducibility, you should. Because we find bugs in libraries all the time, and if you didn't tell me what version of laypack you used, and we find a bug in laypack, even though you weren't using laypack, you were using SciPy, your results are now suspect. And if you can't prove to me that you were using a non-buggy version of laypack or that you were not at risk for this, then 10 years down from the road from now, I might not be able to reuse your research. I might not be able to trust it, right? So again, we're trying to move forward with this ecosystem. We're not trying to rebuild, the wheel from scratch every single time. We're not trying to reinvent it. We want to build cars. So we want to make it easy for people to combine very large, very complicated stacks of software and know exactly what they're working with in a way that you can't do with pip install SciPy. Okay, so of course there are some solutions, right? Let's just pay somebody else to take care of this problem. And there are two ways to solve this problem by paying somebody. The first is sort of this first-class commercial software. You hire a company or you go out to a company like MathWorks and they give you these regular annual releases. And they'll stabilize their package for you. And then there's the worst class commercial software where you're still paying all of this money and you don't get any of these features, right? So maybe you don't want to go and pay somebody else to do it, right? Maybe you want open source software. And actually there are companies that will help you build open source software. That's a separate conversation. But most of the free tools are kind of hard to use, right? So pip doesn't really care about reproducibility. And neither does setup tools. So a lot of the common ecosystem tools that the web developers have given us don't work for our problems. We have to go back to our Unixy roots and to guys like Linus Torvalds and Git. So packaging these source-based scientific software distributions has become a full-time job at numerous places, right? There are companies that do it. There are government labs that do this. There are universities that do this, okay? And so, well, maybe we should just use package managers, right? That seems like a reasonable thing. Okay. Well, so the first door is a system package manager. And this is something that is specific to your operating system, apt-get, homebrew, so on and so forth. And again, this usually only works on one platform. So if I'm on a Mac and I give you my stack and you look at this thing and it's got homebrew on it and you're using Linux, then you're out of luck. So maybe we'll use a language package manager. But the problem with the language package managers is they don't know anything about anything outside of the language, and they don't care. And unfortunately for you, if you're sitting in this room, you are relying on tools that were compiled outside of Python, almost certainly, unless you are a hardcore PyPy developer. And even then, you're probably relying on LLVM. So that doesn't solve all your problems either. Sorry, I'm just going to be the big bad meanie. No, none of you still got lots of problems. But there are solutions. I think Conda is probably the closest to a full package distribution system. The one difference between us and Conda is that we focus more on customizability and providing source-based builds. So, and we also allow you to interact with your host system, where Conda kind of wants a little bit more control. And that's because Conda needs to distribute to hundreds of thousands of people. And usually you're going to be happy with distributing to tens of people or hundreds of people. So it's a question of scale, and it's a little bit of a question about how much effort we want you to make as developers and how we try to make it easier for you to do different things. Okay, so none of your current solutions work. There's only one thing left to do, right? And that's build your own, right? We're all here because we build our own code. So if you're any members of the visit team? Yes, I did a count, Cyrus. 15,000 lines of bash. It was awesome. The Petsy build system, I know none of the Petsy developers are here. 30,000 lines of Python. Dorsal, which sits beneath Phoenix, is 7,000 lines of bash. And HashDist itself, which is our implementation, was about 13,000, 14,000 lines of code the last time I counted. So If you are going to do this, just be aware that you're going to be spending a lot of time, and I don't recommend starting in Bash because you'll quickly outgrow sort of the fun size of a Bash script. An ideal Bash script is about 100 lines of code. After that, it starts becoming not so fun. Okay, so what are we? We are a package manager, and we're also a default collection of packages. So HashDist does all of the building, it does the smart caching, so it's like your pip. HashStack, it's kind of hard to explain. If you know what Conda is, it's like Conda recipes. It's a set of instructions for how to build these packages, but it's very lightweight. We're not a build system, we're not a make, we're not a CMake, we're not setup tools, but what we do say is, well, this is a setup tools package, and this is the most recent release. So I can show you exactly what the HashStack packages look like, but they're fairly straightforward. It's a way to transform a given package somewhere on the web to something that you know how to build on OS X or Linux or Windows. Okay, so we're already at closing thoughts, which means it's demo time. Are there any questions about anything I've sort of promised or talked about so far? Okay, you are all in disbelief. Keep disbelieving. The proof is in the demo. And just to make things extra challenging. Yes?
In the HashTag, do you also keep track of the license of software?
Yes, somebody is adding that.
Aron, can you repeat the question, please?
Yes, oh, sorry. Are licenses being tracked in HashStack? And the answer is somebody cares about this, whether it's GPL or BSD, and they're starting to add this. I'm not doing it, but we have made provisions for somebody to do that. Pull request, welcome. All right, everything we do is BSD licensed, by the way. It's open. Okay, just to make this harder for me, I went to two people, one person that I know really well and one person I don't know at all, and asked them for IPython notebooks that have non-trivial software stacks beneath them. And then I implemented something in front of these notebooks to make them work on any Mac laptop 10.7 or later. If you're a 10.6, you're kind of out of luck. You might need a G4 as well if you're on Mac. So I'm going to show you one or both of these just to make sure that you can't catch me in a lie. I have not distributed these notebooks to you, but I'm happy to send them off, or you can try and get these notebooks yourself. Okay. There's a little bit of magic in here that is not HashDist. In fact, it's a very small little 50-line piece of Python that Min and I wrote this afternoon. And what it does is it takes a look at the IPython notebook, and then this is the actual HashDist. This is called a profile in HashDist. And what it says is that this notebook needs matplotlib to go, because there are pictures in here, and it needs clawpack. And you actually, HashStack already has to know about clawpack. I can't just make up a new package. I have to have, the HashStack has to have at least received a pull request that specifies where it is. But you can maintain your own copy of HashStack, right? And so this using right now is going into the master HashStack repository, but this code is so easy to modify that you can have it point to wherever you want. So you can keep your own fork of HashStack, which is what the Sage developers do, and modify your own packages and maintain your own set. Okay, so that's a specific commit of HashStack, which lists just a bunch of packages. And this says, I want clawpack, but I don't want the one listed in HashStack. I want something from my own Git repository at a specific commit. And so what this is going to pull down now is an environment, create it for me, that has these tools in it, and then it's going to launch the IPython notebook almost so quickly that you're not going to see it. And that's why I'm telling you what is happening right now, just because it's that fast. And it's not that fast because we download, compile, and build that quickly. It's because HashDist is smart about caching things. It doesn't download anything it already has, and it doesn't rebuild things it's already built. And so you can have an infinite number of these profiles based on your hard drive space, which I've found that I can fill up by making lots and lots and lots of builds. Okay. So here we go. We're going to run it. If this works, then we can all jump for joy. This is the first time I've done this demo. Okay. So this is our hacky thing. We're leaving the current IPython notebook, which is just some dumb session. All it knows about is HashDist. It doesn't know about any of the other dependencies. No matplotlib, no clawpack, no nothing. I get dropped into the new session. I can run these cells again and they won't do anything. It actually tells me that I'm in a this works profile. Thanks, Min. If I didn't have Min, then it would have exploded. This is David's. David's over there. You can ask him if you see something really cool. And this is just going to run Clawpack. That's coming down into Clawpack. Clawpack has Fortran. It uses several different packages beneath it. NumPy is one of its dependencies. It uses F2Py. This is all hidden from us. Clawpack actually consists of 4 Git submodules. It's a meta package. All of that is hidden from you. As long as you have a top-level Git commit pointing to a properly sort of denoted repository, it'll take care of the rest. Okay, 1 second. Let me just get the animation to show.
And you need to repeat it when he asks you.
Yes, I will repeat the question, and I will play an animation. Go ahead. Question.
On Mac, you can have multiple compilers. You can have LLVM, you can have a Mac port G++.
I would. Okay, so the question is, what compiler am I using here?
I mean, like,
Yeah.
how do you deal with that? Like,
Okay, how do we deal with the multiple compiler issue? We don't. We're currently only using GCC, and an LLVM stack is in testing. We're getting a lot of help actually from some people from Kitware. Robert Maynard at Kitware is helping with us with that, but it's a really hard problem. There are several people that are interested in this. I'm a little less interested in this because where I use HashDist is on supercomputers. And so I go to a Cray XE6 and somebody has already built a compiler for me and I have to use it. I don't have a choice. So I can actually switch easily between different compiler stacks and that's well supported. Installing your own compiler is supported but not well used. So how am I doing on time?
You have, it's like quarter past 4.
How much time?
3 minutes, I will tell you you have 5 minutes left.
Okay, so I've got plenty of time. Okay, cool. This is probably distracting all of you. Okay, so let me show you another demo just to keep things going, and then mostly just to suspend the disbelief factor. I think this one is a little bit more interesting. And the reason that it's more interesting is not that there's cooler science or anything in it, because I worked with David and David does cool science. This one is cool because we're going to use a different version of IPython. Because this notebook relies on a commit to IPython that is currently a pull request in to IPython. And so you'll see that I'm actually going to Dan's IPython repository. There's a funny thing with GitHub. You can actually pull down the commits from IPython, because the pull requests are actually created as a branch in the main repository when the pull request is created. But that's a side detail. This is a little easier and more straightforward to see. So there is a fork of the IPython repository. Somebody has pushed a commit to it. This is his development version of TrackPy. Again, I had to go and add TrackPy into HashDist, but it took me about 15 minutes. MPL3D, this is Jake Vanderplas's code, and this is a very recent thing. The released version of MPL3D won't work with this code. And then this is actually just junk. You can safely ignore it. Okay. And again, the profile has already been built at some point, so it just links it into for me in the current directory, and I'll show you what that looks like in a second. And then it drops me into the right IPython notebook. It does something incredibly weird. Wow. I've never seen that before. Any IPython developers want to comment?
Dan was playing with reskinning his IPython with some custom.
Not related.
You know.
Your screen's too thin.
Yeah.
That's I think Git submodule problem.
It's a Git submodule problem.
Yeah, I think if you do Git submodule update, it might fix that.
You have 5 minutes left.
Yeah. Interestingly enough, this was working before I didn't see this. So that's really interesting. I don't think it's a Git submodule problem, but thank you for trying. Say again? I think it's a browser zoom problem, actually. It looks to me like something where the, like it being in this weird.
Command 0 to reset.
Command 0? Ah, thank you so much. Whoever said that, have $1. HashDist does not keep track of your browser side or your IPython profile, but I would love to get that in. because that's something that would be really cool to be able to quickly override. Okay, so I'm going to steal some of Dan's thunder here. I'm actually going to show you a widget that has not yet made it into IPython. And you can go and vote on his pull request and say that this is really awesome, because that's a double selector widget. And we got 2 of those, and we've got like kind of a live update with MPL D3. So this is the power of HashDist, is we're enabling you to, in your notebooks, right, encode just a little bit of information that tells people how to use your software environment with this code. And man, there are so many things I want to do with this code that we're not doing. We need developers like mad. There's like so many cool projects. So if you want to get in and get involved with a very small thing, I can name 10 things right away that are improvements. First of all, what's happening here is a little bit of a lie. This only works on Macs, right? Well, it's only tested on a Mac. I have not tested this extensively on Linux. So just even making sure this works on Linux would be great. I'm going to turn to questions. Yes, Sigwin. I know. Yeah. It's okay.
Okay, let's give Aron a round of applause.
Thanks. Absolutely.